Okay, so let us solve DPPs on the chapter Thermodynamics and Thermochemistry. First question of DPP 1. Thermodynamic is concerned with total energy of a system, energy change in a system, rate of chemical change or mass change in nuclear reaction. So thermodynamic is concerned with energy change in a system. Okay. Thermodynamics is already I have taught you the theory. So it is concerned with energy change in a system. Rate of chemical reaction, when we are talking about chemical kinetics chapter, okay, and it does not deal with the total energy, okay, it deals with the energy change. Okay, so whenever I am saying a refrigerator is an example of refrigerator means it's a closed door system, right? So we will say it is a closed system. Clear? Next, if in a container neither mass nor heat, so what I have told you, neither mass nor heat is exchanged, in that case what it will be? Isolated system. I have taught you three types of system: open system, closed system and isolated system. Open system means mass and heat both will exchange. Closed system means mass will not exchange, heat will exchange. Isolated means neither mass nor heat will exchange. Okay, let us see the question number 4. A tightly closed thermo flask contains some ice cube. So what they are saying, tightly closed thermo flask, tightly closed thermo flask. So thermostat flask is an example of isolated system. Have you seen? You will keep cold water in a thermostat bottle, na? So it will remain as it is for longer duration. What does it mean? Heat is not exchanged and it's a closed bottle, so mass will not exchange. So it's an isolated system. Question number 5. Thermodynamic equilibrium involves, okay, chemical equilibrium, yeah, mechanical equilibrium, yes, and thermal equilibrium, yeah. So all of the above, okay. So thermodynamic equilibrium means chemical, mechanical and thermal, all type of equilibrium will coexist. Whenever I am talking about thermodynamic equilibrium, I am not saying just thermal, I am saying thermodynamic. So whenever thermodynamic equilibrium is there, at that point we will get chemical, physical as well as thermal, all the three things in equilibrium. Next, question number 6. The state of a thermodynamic system is described by its measurable macroscopic. Okay, so we are measuring state of thermodynamic system. Okay, let us see the options. So bulk properties, okay, these are, so I have told you what are the factors which can help to measure these state functions, or these are pressure, volume, temperature and amount. Okay, so what are the state variables? Pressure, volume, temperature and amount. Pressure, volume, temperature and amount. Next, thermodynamics is based on initial and final state of a system undergoing to a change. Yeah, so the rate of reaction means chemical kinetics. Physical chemical properties means just physical chemical property does not deal, right? So it depends on the initial and final stage of a system. Clear? Next, which of the following is not a state function? What I have told you, work and heat, whenever you will see, it is our path function. Other than work and heat, everything, everywhere, what we will take? State function. So pressure, state; temperature, state; volume, state; work. Work and heat are the two examples which are not at all state function, they are path function. Just remember these two words, okay? Work and heat are path function, that's all, okay? Next, out of, E means energy, internal energy, H means enthalpy, Q means heat, W means work done, S means entropy, which are state functions. So just now I have told you what are the two things which are path function: heat and work done, heat and work done. So wherever work and heat is there in the option, that we will cancel. So other than heat and work, everything will be state. So EHS, where is EHS? Third option, correct? Okay, now let us see the question number. You are able to understand? Okay, now let us see the question number 10. Which of the following statement are false? Work is a state function. The worst option. Just now I have told you work and heat are path function. If you will sit and solve just DPPs with me, entire concepts will be clear. Okay, even though if you have zero knowledge about thermodynamics, if you will sit and solve DPPs, you will be able to understand. Just what you have to do, take a rough note, okay, take a pen and start writing the star points, the concepts whichever I am teaching you through each and every concept. Every question contain a concept, right? So start writing those concepts. So now when I am teaching, I will teach you concept and then only I will teach you the question. Clear? So all these star point, work and heat are path function. Other than that, state function. Just now I taught you what is closed system, what is open system. Now, so everything you write down in a rough notebook so that you can make a short notes also by the end of this DPP. Clear? Okay. Next, both Q plus W are. So now you tell me Q is path function and Q plus W, first law of thermodynamics formula, delta U is equal to Q plus W, and this Q plus W is delta U. U is change in internal energy and it is a state function. Clear? Very important. So Q path function, no problem, W path function, but when you will add Q plus W, what we get? Delta U, change in internal energy, which is a state function. Over. Now let us see question number 12. Which of the following is not a state function? Pakka W and Q will be there in the option, right? Let us solve question number 2. So which is not a state function? Now you tell me entropy, Gibbs free energy, enthalpy, heat. I have told you heat and work is not a state function, it is a path function. Now let us see next question. Choose the correct answer. A thermodynamic state function is a quantity. So I have designed this DPP in such a way that each and every concepts will be cleared. Okay. So a thermodynamic state function is a, now we are seeing the definition of state function. So state function is that which is independent of path. State function is something which is independent of path. Those who don't know, you write down. State function means independent of path. It depends only on initial and final position. Only depend on initial and final position. But path function, from the name it is clear, it depends on the path. So option number 1, used to determine heat changes. No. Whose value is independent of path? Yeah. So state function is something which is independent of path, only depends on initial and final position. Now let us see question number 14. A thermodynamic quantity is that which is used in thermochemistry, okay, which obey all laws of thermodynamics. Quantity which depends only on the state of the system. Just now we have seen one more question, right? Whenever I am saying thermodynamics quantity, it means it depends on the initial and final position change. Okay, so thermodynamic quantity is that quantity which depends only on the state of the system, which depend only on the state of the system. Okay, mostly this. Okay, next, which of the following is a path function? Which of the following is a path function? Or you tell me quickly. Work done, very good. Okay, work done and heat is a path, other than everything is state. Next, some exceptions are there. We will see that exceptions also. Which of the following are state function? So pakka work done and heat should not be there. Okay, so heat, now heat is our path function. So entropy, Gibbs free energy, enthalpy, everything is a state function. Which option? C option, A, B, C. Next question. A given mass of gas expands from the state A to state B by 3 paths. So there are 3 paths and the gas is expanding by path 1, 2 and 3 as shown in the figure. W1, W2 and W3 respectively be the magnitude of work done. So W1, W2, W3 is a magnitude of work done by the gas along the 3 paths then. Okay. Now you tell me fast, work done is a path function or state function? Path function. So work done will depend on the path, right? Okay. So which option will be correct here? So more the area, more will be the work done. Write down the concept here. More the area, more will be the work done. Okay. When I am talking about the first one, it is covering this much area. When I am talking about second one, this is covering this second area plus that dotted line area. When I am talking about a third one, This will cover this green plus red plus blue, all the three area. So whose area is more? Third path, then second path, then first path. Just now again same question. Internal energy is an example of state function. Clear? Next, the internal energy change when a system goes from state A to B. So internal energy change means they are talking about delta U. Na? Delta U, how much they have given, bacha? 40 kilojoule per mole. In thermodynamics chapter, units are very important. You will make mistakes in the units. Okay. If the system goes from A to B by a reversible path and returns to a state A. So I am starting from A and then going to B, and we are using reversible path. It means again back I am coming to the A. Okay. What would be the change in internal energy? Now you tell me fast. Internal energy is a state function. It only depends on initial and final state. So if initial and final state are same, so change in internal energy will be 0, right? Final, initial also 2, final also 2, 2 minus 2, 0. Change will be 0, very important. Clear? Okay. Now let us see the next question. Intensive property. So before I start intensive, extensive, I will give you a theory about it, right? So you just write down in your notes, make a short notes. What do we mean by intensive property? Intensive property means those who are independent, those who are independent. Okay. Extensive means they will depend, extensive means they will depend, intensive means they will be independent. Okay. So what will go in your short notes? Intensive independent, extensive will depend. What are the 3-4 star points I have taught you during our class lecture? So first star point, you just take any quantity, and you just divide it into two half. Take any quantity and divide into two half. If it will change, then means it is depending, so it is extensive. If it is not changing, means we will say it is intensive. Simple. Okay. Now let us see here. Let's say I am saying length. Let's say I am taking length. Okay. So length I will just break my pen. Okay, if I am breaking my pen from the center, so the length will change or not? Length will change, means length is our extensive property. Length is our extensive property. Now let us take, for example, I have taken an acid X. Okay, the pH of that 1 liter acid I have taken, and the pH of acid is 3. Okay, now I will split it into two half liter in another two container. So will the pH will change? It will become 1.5, 1.5. No, the pH will remain same, means it is intensive property. So I hope it is clear, right? So something which is depending is our extensive, something which is independent is intensive. How will you check? Whatever option is given, take it, try to break it in your brain. Okay, after breaking, if the value is changing, means extensive, it is depending, and if the value is not changing, means it is intensive. Okay, so that is our first star point. Second star point, ratio of two extensive value will be always intensive. Okay, ratio of two extensive will be always intensive. Next star point, all concentration terms, they will be intensive. Molarity, why molarity? If I am saying molarity formula is mole by volume. Mole will change when the number and all are changing. Volume will change if we split into two half. Mole is extensive, volume is extensive, ratio of two extensive, intensive. That is why all concentration term molarity. So every time you will not divide and check, right? So remember this is star point. All the concentration term, molarity, normality, formality, everything will become weight by weight percentage, everything will become intensive. Clear? Okay. Next star point, all energy term, all energy terms are extensive. That's all. Okay, so here we have learned about, so we are not only just solving DPPs side by side, I am making you to write down the short notes also. If you will just attend the DPP session also, na, your chapter will be completed. Okay, and believe me, not a single question will come out of it in your NEET and JEE exam. Over. Now let us solve the question. So intensive property is, okay, mole will change or not, bacha? Mole will change, right? If gas is half, or in, so mole will change, mole depends on the number, mass, everything. Okay, volume, just now I have told you, let's say 1 liter milk, I will split into half, so volume will change if I am splitting into half, so volume is also extensive. Mass, if I will cut you from half, what will happen? Mass will change, mass is also extensive. Temperature, just imagine you have taken a cup of tea, Anna, and the temperature is 20 degrees centigrade. If you will split the tea into 2 cups, it will become 10 degrees centigrade. No, so temperature will not change if you are splitting into 2 halves, means our temperature is intensive property. So I hope you are able to solve the questions by your own. Try the second 21 question by your own. Extensive property is, okay. So question number 21, extensive property is enthalpy. What is enthalpy? Energy, enthalpy, entropy, no, these all are energy, and star point, all energy terms are extensive property. So enthalpy is an extensive property. Density, density never change, right? Water density is 1 gram per ml. My house water, your house water, 10 liter water, 30 liter water, density will be 1 gram per ml. It will not change. Okay. Next, pressure. Pressure will change. Pressure is 1 atm. In my class, 10 student or 100 student, pressure will be same, not changing. Temperature, just now I have explained, intensive. Okay. Next, so you are with each and every question option, you are learning the examples also, which is intensive, which is extensive, right? Next, the intensive property among these quality is enthalpy. Enthalpy is energy. Energy is always extensive. Okay. Mass by volume. Mass is extensive and volume is also extensive. The ratio of two extensive is intensive. Means option number 1, 2 is intensive. Mass extensive, volume extensive. Right? Okay. Now let us, you can say the answer. Your voice will not be recorded. Okay. Try give the answers. In thermodynamics, which of the following is not an intensive? Not an intensive is what they are asking. Extensive. Pressure. Pressure will change? No. It is intensive. Density will change? No. Density is our intensive. Volume. Volume will change? Yeah. So volume is our extensive. Temperature will not change. It is our intensive. So I hope after solving this 4-5 question, it is clear. What do we mean by intensive and what do we mean by extensive? Okay. Solve. Next question, try by your own. Which among the following is an extensive property? Extensive means what? It will change when we are splitting into half. Next star point, all the energy terms are extensive like enthalpy, entropy, Gibbs free energy. Okay. Temperature is intensive. Volume change. It is extensive. Refractive index not change. Intensive. Viscosity is intensive. These two examples you can write down in your short notes. You will forget. Refractive index and viscosity are intensive. Refractive index and viscosity are intensive. Okay. Next question. 25. Which of the following is not an intensive property? Not an intensive means what they are asking. Extensive. For extensive, learn with me. What are the two star points? Extensive means it will change. And the second point I have told you, all energy terms are extensive. Entropy, enthalpy gives free energy. First option is entropy. Entropy is energy or not? Energy. So it is extensive. Okay. Pressure not change, intensive. Temperature not change, intensive. Molar volume. Molar volume is mole per volume, right? So ratio of two extensive property, it is also intensive. Next question number 26. Incorrect statement is R. Let us see the incorrect statement. Density is an intensive property. Correct by density do not change. It is correct. It is intensive. Heat capacity is an intensive property. Okay. So heat capacity, bacha, heat capacity, it is an extensive property. Heat capacity is an extensive property. Okay. So this option is wrong. This option is incorrect only they are asking. Heat capacity, you remember heat capacity also extensive property. Next, internal energy. So energy, I have told you all energy terms are extensive. Correct. All energy terms are extensive. Temperature extensive. No, just now I have told you temperature is intensive. So which is incorrect? B and D option. Which is incorrect? B and D option. Every DPP has almost 30 to 40 questions. At your home, if you will sit and solve, you will not get the motivation, right? So sit along with me and solve. Clear? Okay. Next, which of the following is a state function and also an extensive? It is state function also and also extensive. So pakka state function means work and heat should not be there in the option. Other than work, heat, everything will be our state function. Let us say here internal energy. Yeah, it is our state function plus energy. All energy terms are extensive. So first option itself is correct. So let us choose the second try. Let us see the second option, pressure. So pressure is a state function, okay, fine, but pressure do not change, it is intensive. Now, so state function plus extensive they are asking. Molar heat capacity was extensive, but molar heat capacity is the ratio of two extensive, so it will become intensive, okay. So it is our intensive, temperature intensive. So which option? First option is the correct. So here we have finished our DPP number 1.